Hi everyone, welcome back to Learn with Preeti's channel. In today's section, let's learn about what are the features are introduced in Java 17. Those who are new to my channel, I recommend to watch my previous sections. In my previous sections, I have covered topics which are more frequently asked in Java interview room. Especially, I have covered multi-threading, and string concepts, scenario based questions, and let's get started today with the Java 17. So before watching this, I would recommend you to please subscribe and join with our squad, so that it would reach to the respective audience. And if you really like my video, please drop a like button. And if you have any comments or any suggestion you want to provide to me, please include in the comment section, so that it would be really helpful for my upcoming sections. Yeah, let's get into our today's section. So in Java 17, first we have a sealed class. Sealed class is nothing but we are it's like we are saying the particular class, which class it has to extends. That means here you can see, right, class vehicle, I have marked it as sealed. Here what I'm saying, permits car and bike. So car and bike should extend the class vehicle. If it not extends vehicle, what will happen, we will get a compile time error. Here you can see, right, bike class, I have not extended that with a car class, so I am getting compile time error. And if you see here, here I have included the sealed class. Here in the car class, I extended vehicle and permitted engine. Extended vehicle and permitted engine one. So what I'm saying is, engine class should extend this car. Okay, that's why at the bottom you can see engine should extend the car. These are subclasses, right? Vehicle class is a parent, car, bike, engine, those all are subclasses. Subclasses should be either sealed, final, or not sealed. But the parent class should be sealed or abstract class as well. Okay. Yeah, that's what here we have mentioned. It can be abstract, final, non-sealed, but permitted subclass can be final, sealed, and non-sealed. And can sealed class be interface? Yes, we can keep sealed class as an interface. Okay. Moving on to the next topic, records. Why we are going for records? This I have used in my project. Wherever we feel like we don't want, we need the immutable class. Very important for the interview room. If interviewer asks you to how you will create an immutable class, you can simply go and say like we can create a record with instance variables. Here you can see, right, I have created an employee record with skill and age. What internally compiler will do, compiler will create a final class for this one with skill and age. All the records are immutable, all the fields are private and final. So when you when you create a record, when you create a record, it will be of it is like immutable. No setters will be there, constructors will be there, getters will be generated, toString will be generated, and all fields will be private and final. Okay, fields can be injected during object creation. Here you can see, right, I have added here. But if you see here, I have included list of which is immutable. So when I try to add here, we are getting immutable exception. What you can do, if we change this list of to so object is created, the value cannot be changed. Okay, so because what is happening, when you include this record of, compiler converts into final class with the final list of skill and final age, and constructor getter is generated. So when you try to add this one, you are not supposed to change it because of this list of because list of is immutable. Okay. This is only shallow copy, not a deep copy. What I mean by deep copy means, let me show you one example. Here what we have done, basically here we have added in the list instead of list dot of, and then you can see here I am getting the skills and I am trying to add the data. So I am trying to print the employee. What is happening? I won't get the compile time error. Because the reference is final but the object inside the list is mutable. So primitive fields are effectively immutable. Mutable object inside the record can be still changed internally. So records are shallow immutable, not deeply immutable. That is, if you have this is applicable for anything. Let's say employee, you are trying to add a list of address. Inside the address you want to add any new address, or inside the address object you want to change postcode. That is doable only. But what is inside the record, that is immutable. Okay, not deeply immutable, shallowly immutable, not deeply immutable. Can record implement interface? Printable is an interface. Here you can see, right, it overrides. Yes, it can implement. Here you can see it printed successfully. Here employee dot print what I am doing, system skills plus age. Here you can see, right, skill plus age. Records are replica of final class only. Okay, final class cannot be extended, but it can implement interface. The same concept works for records as well. Next question comes in. Can we create instance variable inside the record? Like something like this format. We will get compile time error because records are meant for transparent immutable. With record fields, record with the constructor, with this constructor, getter, setter, toString, all are created. If you try to add instance method, Java will get a confusion. Instance variable, okay, sorry, not an instance method, instance variable. Java will get a confusion like should I have to use equals compare age toString constructor. So Java avoids adding the instance variable inside the record, instance variable inside the record, but we can add static field. I like this is preferable because static field belong to the class, not belongs to the object. Okay. Can record have constructors? Yes, records can have constructors, even instance and static methods. Okay. Next, can constructor in Java throw checked exception? If not, why? Okay, so whenever you create, this is an one exception class, custom exception. Here you can see it extends exception, which means checked exception. Exception is checked exception. Those who are not know, please we can discuss the exception in later, after some days later. Exception is a checked exception. Okay, so here you can see, right, what we are doing. I'm trying this is a custom constructor. Okay, so what we are doing, if age is less than 40, what we are doing, we are throwing the age check exception. But if you see, compiler is throwing, okay, here is we are throwing checked exception. But why we are getting compiled error? Because when you write record string, compiler internally generates something like this: final class, final string name. Notice here we have no checked exception in the constructor. Record custom constructor must match the record signature explicitly. That is, the generated constructor by compiler is this one, but what we are doing, we are throwing this one. As we are throwing, we have to include throws here in the constructor, but that is not doable. That's why this is not supported. Next question comes in normal Java classes, we can throw checked exception but in constructor, but here it not allows. Why? Because records are strict constructor construct fixed. Java wants to reckon transparent immutable carriers. Solution, what we can do, we can use unchecked exception, the exception which extends runtime exceptions or unchecked exceptions, right, in the custom exception one. So in the above snippet we have extended the class with runtime, so this is a unchecked exception. Here you can see we have a public record class implements printable, which is an interface. Here you can see, right, I have included throw new age check, which is nothing but a unchecked exception. Now this time it not throws any compile time error. Okay, so next, so these are the things we have in the record one. So if I missed, I hope I have covered all the tricky concepts which will be frequently asked in interview for the records and the sealed. If I missed or you want to add anything, please include in the comment section. In the upcoming sections we can listen that we can go through that topic name. Now moving on to the where in Java is used for local variable type preference, meaning here you can see, right, string name Preeti, this can be written as var name Preeti. Compiler will understand this particular is string. Okay, so the rules you have assigned here var x equal to 10. After you should not keep it as empty, it should be initialized. Now here you can see, right, var x equal to 10, inside the method it is allowed, but not as a instance variable of a class, not as a method parameter of method parameter. And here you can see var is not dynamic type. What we are referring, initially we have set var x equal to 10, compiler understood it is a integer. After that if we try to include string, which is wrong. And pattern matching. Okay, these are the thing we have for the var. Now moving on to the next one, which is a pattern matching. Here you can see that object equal to allow. Object is instance of, we are printing this out. If you know, before this pattern matching instance of, we need to typecast. If we receive the string object, we need to typecast and we need to print it, which will be very costly. Not a costly, some 2 plus 4 plus lines will be added. So to avoid that, we have an instance of that compiler will automatically understand and prints it. Okay, here you can see, right, if we have instance, what I need to do, I need to typecast the object into string and then I need to print. So if we include this instance of, automatically it allows us to access, it allows us to perform without doing any typecasting. And is this valid? Valid, because the moment it sees instance of, what it will do, it will convert the object into string format and we are able to access it. But if include the or when, it will fail, because or is like or just can execute, or this is the left hand side, this is the right hand side. This right hand side can execute even if left hand side is fails, but in hunt operator, right hand side will execute only if left hand side executed successfully. Correct? So yeah, this is one of the feature that was introduced in Java 17. And moving on to the next feature, which is switch expression. In legacy switch expression, we need to write result break, right. So in some cases developer may miss to include a break, and next case will be executed. Correct? So it allows us to write something like this. What it will do internally, it will add the break one. So it is a developer friendly, and also you can add multiple cases together. The major one is you no need to add a break in old, in new you can add a break. Why better old switches add bug? Because developer forgot a break sometimes. This is a fall through, right? Java 17 remove that problem. Using a yield, what you can do, when the particular block is executed, you can return that. Why that is? Because you no need to check every case. Correct? The moment you find this particular block, you're simply using the yield and returning. Okay, yield returns a value from the specified block. Yeah, so basically these are the topics we have in the Java 17. So I hope this is a really helpful section, and this had helped you to understand more on the Java 17 feature. Please like and subscribe. Thanks for watching my video. Have a great day. Take care. Bye bye.